Mechanics 2022. Question number 1. In this question, position vectors are given relative to a fixed origin. At time t seconds, where t is greater than 0, a particle has velocity v meters per second, where v is given by that expression. Find the speed of p at time t equals to 2 seconds. So we put t equals to 2 in the expression for v, and we use Pythagoras. So we put t equals to 2, and then we would use Pythagoras to get 6 meters per second. And I've got here the Pythagoras formula, just to remind you. So this is when you put t equals to 2. So 2 squared is 4. 4 times 3 is 12. And you put t equals to 2 there, 2 to the power half times 6. So this is what it looks like. 12 to the right and minus 6 with 2j down. And then we use 12 squared plus 6 with 2 squared. And that gives you 6 meters per second. Part B, find an expression in terms of t, I and j for the acceleration of p at time t seconds, where t is greater than 0. I'll put here some formula. Velocity, ds over dt. Acceleration is differentiating velocity, or you're differentiating displacement twice. So it's very important to understand this formula. So we know what the velocity is. To get the acceleration, we differentiate velocity. When you differentiate 3t squared, you get 6t. You differentiate 6t to the half, you get 3t to the minus a half. So that's the expression for acceleration. So your final answer, you can write it neatly. We've written it neatly there. Meters per second squared. Part C. At time t equals to 4 seconds, position vector of p is I minus 4jm. Find the position vector of p at time t equals to 1 second. Since we want position, we have to integrate the velocity. So the position, we call it r, integral of velocity with respect to time. So that's the expression for the velocity there. So we're going to integrate that expression. To integrate, add 1 to the power, divide by the new power. So 2 plus 1 becomes 3, and then you divide by 3, and this 3 will cancel. You get t cubed. You do the same, add 1 to the power. 1 plus a half is 3 over 2, and then you divide by 3 over 2. When you simplify it, you'll get this expression there. Now, it tells us that t is equals to 4, and r is that I minus 4j. So what we want to do, we want to find c. C is this constant of integration. So we substitute what t and r are. So we put the position I minus 4j, and then we sub in t to be 4. So the 4 cubed minus 4 plus 4 times 4 to the 3 over 2. We rearrange all of this to find c. So we put c to the right-hand side. Rearrange all of that. We got c to be minus 63i plus 4j. So you can write your expression with the c at the end. So you want your position with the c at the end. So when you want to find, you find it when t equals to 1. So you put t is 1 there, put t is 1 there, and you put all the i's together. So 1 minus 63 is minus 62i. And then put the j's together. You got 24j. That's your final answer then. Question number 2. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha is 1/2. So sometimes tan alpha may be 3/4. So we'll do it when tan alpha is 3/4, and then also look at it when tan alpha is 1/2. A small block B of mass 5 kg is held in equilibrium on the plane by a horizontal force of magnitude X newtons as shown in figure 1. And that's figure 1 there. The force acts in a vertical plane which contains a line of greatest slope of the inclined plane. The block B is modeled as a particle. The magnitude of the normal reaction of the plane on B is 68.6 Newton. Using the model, find the magnitude of the frictional force acting on B. So I've highlighted some of the important things there, like the 5 kg equilibrium, 68 for the reaction, frictional force. And for this type of question, we need to do a very good diagram. So one of the things to notice is, you see the Z there in the yellow at the top corner. I'm using the idea that alternate angles are equal. So when you do the diagram, there's the vertical force, the weight coming down, which we call mg. W is equals to mg. We have the normal reaction there, 68.6. And the frictional force pulling it up to stop it sliding down. Frictional force opposes motion. So it's pulling it up. We'll put it to go up to be mu r. And I'll explain why we use it going up at the moment. This force X Newton is pushing on the object. So why do we use F equals to mu r, pointing it up? We do not know which direction is going to be. F is going to, it could be going up or it could be going down. We do not know. We have just chosen going up. It makes the diagram look neater. But when we calculate it from the sign, we would know. So let's use up for now. Frictional force is going up. This is what you want to think of. If this force pushing it is very large, this thing will be going up this inclined plane. So frictional will be opposing it, will be going but down. Think about it. If you were pushing with very large force, this object will be going up the hill, up the slope. So friction is opposing motion, it will be going but down. But if this force is small, and the thing will be trying to slide down, so friction will be up. That's another way to think about it. Now we change this angle alpha is the same with this angle alpha there. You can look at trigonometry to figure that out. And this, looking at this triangle, I put in there in the red there, the triangle. The hypotenuse is mg. This one adjacent to this angle we call mg cos theta. So this is mg cos theta. And the one opposite, this one going downwards, force is mg sin theta. We take the X Newton force, we have to resolve that force into 2. This angle there is alpha. And why is it alpha? I use that alternate angle thing. If you look at the Z in yellow, this angle alpha is same like that. So sine alpha is opposite over hypotenuse. Hypotenuse is, so what we do now, this is the 90 degrees there. So it's very important to say that's the 90 degrees there. So we got this one to be opposite over hypotenuse. And then we get X sine alpha and X cos alpha. If we use tan alpha is 3/4, 3/4. Tangent is opposite over adjacent, and then we can get sine alpha and then cos alpha. If we use tan alpha is 1/2, We use Pythagoras, so sine alpha is 1 over root 5 and cos alpha is 2 over root 5. Resolve perpendicular to the slope. So total upward force is equal to the total downward force. So how many forces are pulling it up is 68.6, and pulling down is 2 of them, x sine alpha plus 5g cos alpha. Rearrange that, you get this for x. Substitute in cos alpha and g. We are using 4 over 5 in this case. So, and we put sine alpha 3 over 5. So x would give you 49. So after that, we resolve parallel to the slope. Total force is pushing it up. So total upward force parallel to the slope is equal to the total downward force parallel to the slope. So the force going up parallel to the slope, F plus x cos alpha, and the one going downward is 5g sine alpha. So now we can rearrange it to get F. So F would be 5g sine alpha minus x cos alpha. You sub in sine alpha, sub in cos alpha, you get F is minus 9.8. Now, because F is minus 9.8, its minus is because when we drew it, the friction was going up. So the minus is telling us that the friction was supposed to be going down. So our F now, we will conclude that our F is 9.8 down the slope. That's what we'll conclude for that one. And if we use tan alpha is equals to a half, we use that same, everything the same above, substitute into x, we will get that value for x. And when F is pointing down the slope, we substitute all of that and simplify. So we can put F plus 5g sine alpha equals to x cos alpha. We solve it to get F is 27.6. So we say state the direction of the frictional force acting on B. So the direction is down the plane. The horizontal force of magnitude x newtons is now removed and B moves down the plane. Given that the coefficient of friction between B and the plane is 0.5, find the acceleration of B down the plane. So we want the equation of motion down the plane. So 5g sine alpha minus 5 equals to 5a. So we're using that F equals to ma, Newton's second law, the net force. So there's a reaction, F moving upwards, 5g cos alpha, 5g sine alpha. So the diagram shows clearly, and the acceleration is going down the plane. So we resolve perpendicular to the plane. So perpendicular means at right angle to the plane, 90 degrees. So everything going up is R, everything going down is 5g cos alpha. So F is equal to 0.5 times R. So that gives you 0.5 times 5g cos alpha. And 5g sine alpha minus F is equals to 5a. So 5g sine alpha minus, replace F with 0.5 times 5g cos alpha is 5a. Make A the subject, and then the 5 will cancel out. And then you substitute the values for sine alpha and cos alpha, and you get A to be 1.96 meters per second squared. Question number 3. A particle of mass 4 kilograms is at rest at the point A on a smooth horizontal plane. At time t equals to 0, two forces, F1, 4I minus j Newton, F2, lambda I plus mu j newtons, where lambda and mu are constants, are applied to P. Given that P moves in the direction of the vector 3I plus j, show that lambda minus 3 mu plus 7 equals to 0. So we draw this triangle, 3 and 1. So we add the two forces, F1 plus F2. F1 plus F2. And I put it in column form. So 4 plus lambda minus 1 plus mu. And we can write it this way, 4I minus j plus lambda I plus mu j. So it gives us the 4 plus lambda I minus 1 plus mu j. So if we put that equals to 3I plus j, we use ratios to obtain an equation in lambda and mu only. So that's the part which you have to, you really need to understand. When you use ratios to find an equation in lambda and mu, that means what is in front of I divided by what is in front of j should be equal to what is in front of I there divided by what is in front of j. What we need to say is we need what is in front of the i's. What's in front of the I is 3. Is 3 times bigger than what is in front of j. What's in front of j is 1. What's in front of I is 3. The word 1 in front of I is 3 times bigger than what's in front of j. So remember that idea. What's in front of I divided by what's in front of j should be equals to what's in front of I divided by what's in front of j. And then to solve that, you cross multiply. 4 plus lambda times 1 is equals to that expression there. And then you rearrange it to get this answer there, to put lambda minus 3 mu plus 7 equals to 0. At time t equals to 4 seconds, P passes through the point B. Given that lambda equals to 2, find the length of AB. So lambda equals to 2, you substitute 2 in there. So 2 plus 7 is 9. You take it to the other side, it becomes minus 9. So mu is equals to 3. So we got F1 is equals to 4I minus j. We got F2 is lambda and mu. So when we add F1 plus F2, it becomes 4 plus lambda and 1 minus 1 plus mu. But do we know what lambda is? Yes, lambda is 2. Do we know what mu is? Yes, mu is 3. So we replace lambda and mu. 4 plus 2 is 6, minus 1 plus 3 is 2. So the resultant force would be 6I plus 2j, and of course, newtons of force. M equals to 4. So we're using F equals to MA. So F equals to 4A. So we know 6I plus 2j is equals to 4A. Do we know what A is? A would be 1 over 4 times 6I bracket 6I plus 2j. We make A the subject. Using S equals to UT plus half AT squared, with U equals to 0 and A and T equals to 4, to find the length AB, which we call it S then, the displacement. So S is 0 for U times 4 for T plus half times A times 4 for T squared. So S equals to 8A. Now we know what A is. 1 over 4, let's go to what A is. 1 over 4 times 6 is 6/4, which is 1.5. 1/4 times 2 is 2/4, which is 0.5. So A is 1.5i plus 0.5j. And the magnitude of A is 1.5 squared plus 0.5 squared. So we would use that for A there. So S is equals to 8 times that expression, and that gives us 4√10. And that S is the AB. And that rounds up to 13 meters. So what we have used, we've used Pythagoras right there to find the magnitude of A. And we've used this silver there. We're finding AB. We know U is 0. We don't know the final velocity. We know what A is. We know what for the time is. So that use the silver to help you. So your answer there, 13 meters, or exactly 4/10. Question number 4. A uniform rod of mass M and length 2a. The uniform means the mass acts through the center, or the weight acts through the center. So a particle of mass 2m is attached to the rod at point C, where AC equals to 1.5a. The rod rests with its end A on a rough horizontal ground. The rod is held in equilibrium at an angle theta to the ground by a light string that is attached to the end B of the rod. The string is perpendicular to the rod as shown in figure 2. Explain why the frictional force acting on the rod at A acts horizontally to the right on the diagram. The horizontal component of T acts to the left. And since the only other horizontal force is friction, it must act to the right. So if we have T sine theta is equals to F, and then the tension in the string is T, show that T equals to 2 mg cos theta. Have a look at this diagram. I'm going just for that part A only. If you look at this, what I circled there on the top right there, T sine theta, this force is acting towards the left side. That T sine theta, watch that, is acting towards the left. So if this system is balanced, we need a force acting towards the right. So you can see the red line there. The force there acting towards the left is T sine theta. And this one acting towards the right is F. Because the system is balanced, what is acting to the left has to be equal to what's pushing to the right. So that means T sine theta equals to F. And if we go back to that part A, explain why the frictional force acting on the rod at A acts horizontally to the right on the diagram to balance T sine theta acting to the left. So the T sine theta, which was acting to the left, has to be balanced with the F down there. So they are equal. So it doesn't move. So if this is 4 newtons, this will be 4 newtons. Very important. So to balance the force acting at the top. So if we look at the diagram, we have 2 mg. So this is 2 mg cos theta. And this is mg cos theta. And the force act, the one going down, mg sine theta. And this one should be 2 mg sine theta. 2 mg sine theta. Pulling it downwards. So using this, that triangle there, one triangle, two triangles, and then this distance is 1.5 A up to that point C, that distance is 1.5. If this, look at that yellow triangle there, Z, the alternate angles are equal. So this is theta and this angle is theta. And then that's the reaction there. And if you come to the top, in this top part here, from the geometry, this angle is theta. That's 90. So 90 minus theta is this one. So this angle there is theta. So using this triangle at the top corner there, this one is T sine theta opposite over hypotenuse, T sine theta, and this one is T cos theta. So we want to resolve that into T sine theta and T cos theta. We come here, we resolve this one into 2mg cos theta, 2mg sine theta. We come here, we resolve this one into mg cos theta and mg sine theta. So very important to get those things right, because when you start to do the question, it's easier then. So the tension in the string T is T. Show that T is 2mg cos theta. So what we want to do, we want to take moments about A. Why do we take moments about A? Because do we know what R is? No. Do we know what F is? No. So you want to take moments about A because the distance from R to A is 0. The distance from F to A is 0. So their moment is force times the distance. So the force of R times the distance of 0 will be 0. And for the F, the moment of F is the friction F times the distance, which is 0, is 0. So these two will be 0. So make the question easier to do. So take moments about A. So we need to find the equation. So moments is given by force times distance. So we want to look at anti-clockwise moment and clockwise moment. Anti-clockwise, think of the clock. Anti-clockwise is the mg cos theta times A. And clockwise, let me put that, not mg cos theta times A. Let me explain that again to you. Put it smaller so you can see clearly. The T there, that force T there, that's the one going anti-clockwise. I put it there in green. That T there, the distance from T to the moment point to A, that distance is 2A. So that distance is 2A, and that's T there. So and this perpendicular distance. So it's T times that distance, which is 2A, is equals to, we want to use the clockwise moment. Mg is this force pulling down, mg cos theta is this one, and the distance from there to that point is A. The next force pulling down is 2mg cos theta, and that distance is 1.5A. 1.5 is that distance there. So 1.5A is the distance, and then the force is 2mg cos theta, 2mg cos theta. For this one, the force is mg cos theta, and the distance is A. Now we want to rearrange that. Cross out the A, acceleration, and then you have 2t is equal to that expression. You do 2 times 1.5, it gives you the 3 there. You add the 1 mg cos theta plus 3 mg cos theta, you get 4 mg cos theta. You rearrange it, you get t equals to 2 mg cos theta. Given that cos theta equals to 3/5, show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg/25. What we want to look at is the total upward force equal to the total downward force. It's very important to remember that. Or you can just say resolve vertically. But what does that mean? All the forces going up should be equal to all the forces going down. So if you look on the diagram, all the forces going up is R plus T cos theta is equals to the two of them going down, mg plus 2mg. I'll show you the forces on the diagram. R is going up and T is going up. Going down, mg is going down, 2mg is going down. Two forces going up, two forces going down. So add the forces going up, add the forces going down, and make them equal to each other. So now we'll make R the subject. mg plus 2mg is 3mg. We'll make R the subject. Now, we want to replace T. We want to replace T because we don't have T in the answer. If you look at the answer, there's no T in it. That's the thing, the trick in this type of question. Look at the answer. What you want to get to, there's no T. So you know you have to replace T. So we know T is 2mg cos theta. So you replace T with that 2mg cos theta. And from there now you substitute for cos theta. And then you will do the numbers with your calculator. 3 minus 18 over 25. And then you get 57 over 25 mg. The coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, show that mu is 8 over 19. We look at the total forward force is equals to the total backward force. Or they would say resolve horizontally. What does resolve horizontally means? Everything pulling it forward is equals to everything pulling it backwards. That's the way I learn it. And then you find the equation. So resolving horizontally, we got F from that diagram. You remember we had F pulling to the right. T sine theta was at the top pulling to the left. So, but we know T is 2mg cos theta. So we replace T there with 2mg cos theta. And then, but we know F is mu R. So we replace F with mu R. So we're doing replacing F and replacing T. So when you replace F with mu R, and then you rearrange it, of course, cos theta and sine theta, we got it from those triangles there. When you rearrange it, you get R to be that. So your mu, replacing R with that expression there, your mu is equal, your mu times R is equals to 2mg times that cos is 3 over 5 times the sine is 4 over 5. The mg's will cancel on both sides. Now you will take the right-hand side, 2 times the right-hand side divided by 57 over 25. Put on your calculator, you get mu to be 8 over 19. Question number 5. A golf ball is at rest at point A on horizontal ground. The ball is hit and initially moves at an angle alpha to the horizon to the ground. The ball first hits the ground at the point B, where AB is 120 meters, as shown in figure 3. The motion of the ball is modeled as that of a particle moving freely under gravity, whose initial speed is u meters per second. Using this model, show that u squared sine alpha cos alpha equals to 588. I put some formula here for horizontal motion of a projectile, constant velocity, so the acceleration is 0. So the formula is distance is speed times time, velocity times time. And then when you resolve the forces, The horizontal is u cos alpha. The horizontal component u cos alpha. The vertical component is u sine alpha. So we have S is equals to V times T. So velocity is horizontally is u cos alpha times T, and that's equals to 120. The vertical component, S equals to ut plus half at squared. S is 0. So we put A equals to G. So when the ball hits the ground, S is 0. So we use vertical motion for the formula. U sine alpha times T minus, because it's going up and G is plus coming down. So that what makes it the minus half gt squared. We solve this question by eliminating T. That means we get rid of T. Now we got u cos alpha times T is 120. We want to make T the subject. So T is 120 over u cos alpha. Now we take that and replace T in that other formula. So we're replacing T. So we got u sine alpha times T. We replace it with 120 over u cos alpha. Minus half G. Instead of T squared, we will 120 over u cos alpha squared. And all of that is equals to 0 because it has landed. So the displacement is 0. So now we want to solve all of this. This is all has to do now with how you solve that quickly. This u would cancel with that u there. And then when we have another way to look at it, you divide all of them by 120. So 120 will cancel on the left, 120 will cancel on the right because I'm dividing all of them by 120. You times all of them by cos alpha. When you times by cos alpha, this will cancel that, and one of these cos alpha on the right will cancel. So you end up with sine alpha minus 60g, because 120 divided by 2 is 60. So you end up with 60g over u squared cos alpha equals to 0. You can multiply all of them by u squared cos alpha. Multiply by u squared cos alpha, so you get sine alpha times u squared cos alpha minus the u squared cos alpha will cancel there, minus 60g equals to 0. Take the minus 60g to the right. So it's 60 times the g is 9.8. So you get u squared sine alpha. We put the u squared in front and the sine alpha and cos alpha. So that gives you the u squared sine alpha cos alpha. 60 times 9.8, it gives you 588. The ball reaches a maximum height of 10 meters above the ground. Show that u squared is 1,960. So I put some information here. A projectile reaches its point of greatest height when the vertical component of a velocity is equals to 0. So if we have v squared equals to u squared plus 2a as the Sievert equation, we write Sievert. The maximum height is 10 meters. Initial vertical speed u sine alpha. At that maximum, the greatest height, the velocity is 0. So final velocity is 0 because it stops moving momentarily. It goes up and stops before it starts coming down. Acceleration is g, and we don't know what the time is. So using that v is 0, so 0 squared plus u sine alpha squared minus 2 g times 10. We use minus because we use going up is minus g. Coming down is plus g. So put minus 2g times 10 to the right, it becomes plus 2g times 10. Make u squared the subject. U squared will be 2g times 10 over sine squared alpha. So now we know u squared sine alpha cos alpha is 588. So we want to rearrange that such that we have u squared sine alpha is equals to 20g, which is 196. So u squared is 588 over sine alpha cos alpha. So you just go from this first one to this one to get what u squared is. So we know what u squared is. 588 over sine alpha cos alpha. So u squared times the sine squared alpha is equals to 196. Watch this carefully. U squared times sine squared alpha is equals to 196. And sine alpha will cancel one of the sine alpha. So you go sine alpha divided by cos alpha, it gives you tan alpha. So 588 tan alpha equals to 196. So find tan alpha, it gives you 1/3. So you go into the triangle. Tan alpha is opposite over adjacent, 1/3. So this will be √10. So sine alpha is 1/10. Opposite over hypotenuse. Sine squared alpha is 1/10 squared, which is 1/10. Now, on the formula for u squared is 2g times 10 over sine squared, but we know sine is 1/10. So if you put that, so sine squared is 1/10. So sine squared is 1/10. Put 1/10 there, and that gives you u squared to be 1960. So just to quickly recap what we're doing with all this rearranging and sub in here. We started with u squared is equals to u squared sine alpha cos alpha is 588. We made u squared the subject. And then what we did now was we arrange and we simplify by changing sine over cos to be tangent. Use a triangle to find what sine is, and then square the sine to get sine squared. So what we wanted to do to solve that, I put in circle there, was to find out what is sine squared equals to. What is sine squared alpha? So we did all of this to find sine squared alpha to be 1/10 and put it in there to get the 1960. In a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modeled as that of a particle whose initial speed is v meters per second. This refined model is used to calculate a value for v. State which is greater, u or v, giving a reason for your answer. V, since air resistance has to overcome, or just because of air resistance. So V is greater than U. That means you have to throw it harder because of air resistance. When there's air resistance, you have to throw it harder. Part D, state one further refinement to the model that would make the model more realistic. Usually it's air resistance, but they've used air resistance in the first part. We can think of the wind effects. The wind could be spinning. We use a more accurate value of G. We have used G as 9.8. It could be 9.81 something, something, accurate value of G. Another reason, the ball could be spinning. Like when you play cricket, they spin the ball. It affects it. The size of the ball, a small ball or a bigger one would affect it. The shape of the ball, a football or a rugby ball, is different shapes. The dimensions of the ball. So they will treat the ball as it's not a particle. Variable acceleration, the acceleration is changing. It doesn't stay the same. Another thing you can say, the surface area of the ball. Humidity. So you can say wind resistance or rotational resistance. So pick any of these and write, and that should be fine. Any of them, there are quite a lot of them there. So to help you really understand projectile motion, the information 1, 2, 3, and 4 and 5 on this page are the things you just need to, if I were you, memorize them, except this last equation is quite long to memorize. But memorize all of this information. It's what you need to do projectile motion. The constant velocity acceleration is 0, s is vt. The horizontal u cos alpha, the vertical u sine alpha, the time of flight, time to reach greatest height, the range for horizontal plane. These ones, you can learn these ones I've ticked. Saves you time in exams and builds your confidence.